Hello, my name is Daniel Iwaka. I'm Chief Software Architect at Physical Technologies, a software company based right here in Reading. As you can see, I'm taking the perhaps controversial position that the idea that there's a job title prompt engineer is based on a misunderstanding. There's such a thing as prompt engineering, which is what we're going to talk about here. Hence, there must be such a thing as a prompt engineer. But this is an unfortunate back formation of a word from another word and doesn't make sense. On this, I'm with John Stewart, who mocked this idea a few weeks ago with the idea of types question guy. It's actually the guy on the left he's quoting, who is Microsoft's CEO, Satya Nadella. If you look up the video of Nadella making those remarks, I found one of them with a single comment: "I want this cool job." And now on YouTube, you can never tell if people are being sarcastic. But you will, of course, noticed over the last few years, especially since the third generation of ChatGPT around 2020, that the hype around AI has grown explosively. Large language models have become vastly better since then, surprising many people with what they're capable of, including the people who build them, which has only fueled the hype explosion even further to the point where it's entered the mainstream, which means that most of what you hear about it is wild speculation, exaggeration, scaremongering, and politics, which, by the way, accounts for about 80% of that John Stewart clip, if you look it up. Not just what he's saying, but also the various CEOs that he quotes. But when prompt engineering is carried out interactively by a person, it looks something like this. This is the dream, that you can converse with the software to explain what you want and it understands you. In other words, it's not a specific job title, it's how everyone interacts with the technology. When refrigerators came along, we didn't invent the job of a person who stands by your fridge and opens the door and takes things out for you and puts them back in. We can all do it. It's natural. The technology has met us better than halfway. It's already adapted to our needs. So what we need to do is figure out how to integrate these new natural language capabilities with our existing products. And there have been predictable high-profile disasters where a chat window has been bolted onto an existing website and it goes rogue. It's very easy to get it to swear, be offensive, and verbally attack the very service it's being hosted by. So what about a more customized integration? You can easily find a ton of tutorials on integrating with large language models, and they typically walk you through examples where the goal is to have the service generate human-like text output, taking records from a catalog of products, projecting them into friendly, wordy descriptions with a particular mood. And this is understandable because it's the most obvious way in which LLMs are impressive and novel. But I'm more excited about the ability of LLMs to work the opposite way and turn loose or vague human language requests into objects that conform to a rigid specification and can therefore be easily consumed by our existing software. Now, a simple experiment with this will suggest that it's not necessarily that easy. Here's an example I found where someone was struggling a little bit. They are somewhat specific in the first prompt. They say JSON no less than 4 times. They do misspell a couple of words. The first response corrects the spelling of summary. And then they ask an actual question and it forgets the requirement to answer in JSON. But also they never make it clear what the properties of the object are for. What's the tone of the JFK question and how could it be summarized further when it's only 3 words long? Anyway, here's how we got somewhere with this idea. Some background. At Fiscal, we offer a SaaS product where our customers, who range through local government, healthcare, education providers, and wider industry, upload records of their payments and the suppliers they use, and we analyze the data for patterns in the spending and identify anomalies, not just potential fraud, but more often honest mistakes, which are surprisingly extremely commonplace, even with the protections in modern ERP systems that most medium to large businesses run on today. It's not unusual for our product to pay for itself in the first few weeks, as hundreds of thousands of dollars or pounds of accidental payments are uncovered by our pattern finding algorithms. Our core server-side code base is C#, supported by SQL Server in Azure and some Python. We mainly focus on building out predefined views to allow the user to explore the findings from our processing of their data, steering the user in very specific directions. And that's always going to be the main focus of our work, because that's the true value of such a product, really understanding the user's problem for them and being ready with the answers that they need. But last year we decided to offer far greater flexibility and allow users to build their own dashboards to explore their data however they want to. These dashboards are made up of tiles, each tile being a graphical or table view of an analytical query. Very standard stuff. It roughly equates to a SQL group by. So you can choose multiple values to group by and multiple values to aggregate over count, sum, and average. So we need to have this quite flexible tile editor. This is pretty much letting you build the group by query of your choice with quite a lot of power, albeit within a proper sandbox that enforces data security. Now, it's all very well letting your users have that kind of power, but it's not much good if they aren't going to learn to think like a SQL query author. Using drop downs and buttons means they don't have to use the query language syntax and learn it, but they still have to think carefully about how to get the result they want, which is the hard part. Syntax is the easy part of coding, which means that to some extent we've made it more accessible. We've made the easy part easy, while the hard part, the conceptual part, is still as difficult as ever. There's still a language here, a vocabulary of concepts that has to be learned and understood. What if users could type into a box in plain English what kind of chart they want to see on their dashboard? It might look like this. You just type something in the box and the tile editor updates according to your request. You could use it to make a small change to an existing tile or change the tile completely to show you something different depending on what you ask. So how can we get OpenAI to help us with this? We need to think carefully about what an LLM is, what it's trained with. It's read a lot of code and documentation. It knows standard coding languages very well. So here I set up the scenario that I'm going to describe a chart that I want to draw, and I'd like to see the SQL that might get the data for such a chart, given a simplified description of the database schema. And it comes back with something quite plausible. And this would be a great starting point if you're going to then incorporate that into your code base. But it has a lot of problems given our aim to totally automate this process. It's not at all secure to agree to execute whatever code you receive from an external system, especially if a user prompted it. We can't accept instructions at such a low level. Real databases have extra filters that need to be applied to stop users seeing all rows based on an app-specific security model. The results here are partly in plain English and require more finessing to make them right. We didn't tell it the DB schema, so it just invented a plausible one. But in our dashboards, the way we store the configuration for a tile is in a specific JSON format. When you're editing a tile, you're really editing a snippet of JSON that says what you want to group by, what you want to aggregate over, how you want to filter the data. In other words, we've lifted the idea of a query to a higher level, more restricted description that still has some flexibility, but no ability to bypass our fundamental security model. So what if we write a declaration for this JSON format and included it in the prompt? We could use JSON schema. It's fairly widely used, though not as much as JSON itself. But even better, we can use TypeScript, as that is very widely used for describing JavaScript structures. So GPT will know exactly what we mean and it's more succinct as well. This is something we could auto-generate from the same data we use to populate the tile editor UI. It's quite big. These are just the first few examples of each type of thing. So it can be several thousand tokens if we include the complete set of features. Tokens being the units by which GPT measures the amount of context you provide. So there's a list of all the available metrics, the aggregations, the groupings, and those are just strings. But there are also filters, which can be more sophisticated. They have their own nested configuration. And these lists can change depending on what set of features the user bought. So yeah, it's got to be dynamically generated per customer. We include comments next to the items to give GPT more of a hint as to the purpose of each setting. Basically, we're going to flood it with context so that it has a lot of information to work with. And then we include this overall structure of a query, which ties everything together. So then in any subsequent plain English part of the prompt, we can always be very clear that we'll be sending and receiving JSON that conforms to the query type, this specific query type. So we can send the current configuration of the tile along with the user's prompt and then get back a new configuration. We can then validate and fix it up to make sure it's conformant in ways that aren't necessarily described in the context we send. Although we could include more hints about that in the context. Sometimes the JSON we'll get back has comments in it, which is not strictly JSON compliant, but they're easy to strip out. So our high-level schematic diagrams like this: the user enters plain text prompt, that gets sent to our service. We combine it with the automatically generated TypeScript context and a bit of plain English to set the scene, and the current tile JSON, and the user's prompt. And we give that to the GPT service and we get back new tile JSON. So let's give it a spin. This request is very garbled, but it's got two different numbers we want to track mixed into the same chart. And it says by quarter, which is very sensitive couple of words. Lots of different things that could mean depending on the situation. So it's short, but it's by no means the simplest thing you can ask for. And we've given GPT so much context, it gets exactly what we want it to do, and the tile editor updates right away to look like this. We've got the two metrics in there that produce the two lines. We've got the right chart style. It's using the date resolution of calendar quarter, which is a perfectly reasonable guess based on the vague suggestion in our request. What's really cool is that it's put good descriptions on the axes. It made use of a good mixture of what I said in the prompt and also what our schema uses as terminology. It's just generally made excellent choices. Because we send it the existing state of the tile configuration with each request, you can make spot edits to particular things. And also we can have a bit of fun and do something like this. Make the labels be like a pirate talking. And we get amusing labels. Amount spent matey and credit rate me hearties. It can also sometimes mention doubloons and pieces of 8. So to give you some idea of the rapid advances in this area, technically when we first thought about doing this, it wasn't really practical to do so. That was in the first half of last year, at which time the maximum number of tokens you could send in a request was about 4,000. With all the details we want to send about our schema, the generated TypeScript part alone can easily blast through that limit. And then in the middle of last year, OpenAI made a special version of the model that supported 16,000 tokens. So you could send it a pretty long academic paper and say, understand this for me. You can see this guy, he got very excited about this. It was more expensive per token, but it was plenty for us to try out the big TypeScript context approach for the first time. And then at the end of the year, they announced that in early 2024, the 16K limit would become the default. And also, if you look here, you can see that they're specifically calling out that they've made it better at generating JSON for precisely this kind of use case. So it's becoming a very standard thing. And at that time, they mentioned GPT-4 was becoming more mainstream, becoming cheaper and faster. And now has an incredibly large context limit. So you can send it an entire novel and get a summary, which is a real time saver, as I'm sure you'll agree if you've ever tried to read a novel. And if you're using Azure as your cloud platform, because of the close ties between OpenAI and Microsoft, you can just go on there and create your own private instance of OpenAI. Choose whatever models you want to have available. And we found that the performance is a lot more predictable and snappy with that setup compared to the OpenAI service. It also integrates with the Azure authentication model. So you can create managed identities that your processes run under and grant those identities access to our GPT instance. And you can see here, we've created a service registered in our DI, which we can inject anywhere we want to take advantage of GPT capabilities. You pass it a sequence of messages, you get back a sequence of messages. It takes care of all the authentication, so it's super easy to integrate into any existing feature. And now a word about costs. On Azure at the moment, 1,000 input tokens costs 0.04 of a penny. So if you're sending 5,000 tokens of context in every request, then a request is 0.2 of a penny, a fifth of a penny. So this is expensive or not, depending on what kind of usage pattern you're expecting. It really depends. In our application, we're not expecting all our users to be doing this all the time. In fact, it's more of an occasional configuration change to set up the dashboards they want. So for us, in this case, the cost per customer is negligible. But if you did one such request a second for a year, it would cost £63,000. So it will depend. So I hope this has been a useful look at a way of incorporating natural languages into an existing product while avoiding the usual scaremongering about the end of the world being just around the corner when the machines take over. Thank you.